Hello 7th graders, today we meet again in online learning SMPK Penabur. I hope all of us and all of our family still in a good condition. After we have learned about area or superficial expansion at previous meeting, at today's meeting we will learn about volume or cubical expansion. Standard competence for our topic today is 3.7. Understand the concept of temperature, expansion, heat transfer, and their application in the mechanism of maintaining body temperature stability in humans and animals in daily life. And 4.10, conduct the experiment to investigate temperature and its change and the effect of heat in temperature and state changes. Volume or cubical expansion. To understand about volume expansion, firstly we will see the figure of volume expansion. Let's see the figure below. At the left figure, we see that the metal ball can pass through the ring before it is heated. And at the right figure, we see that the metal ball can pass through the ring after the ball is heated. And the next figure, we see that the metal bar exactly fits the box. And the last figure, we see that the metal bar can put into the box after it is heated. Volume expansion. If the solid bulk object is heated, it will expand. Because of its height, its length, and its width quite big, so the expansion happens on direction of height, length, and width. This kind of expansion we call as volume expansion or cubical expansion. To understand about volume expansion, let's see the figure below. At the left figure, we can see there is a cube which has length L0, which has width L0, which has height L0. So the volume of the cube is V0. That V0 equals L0 times L0 times L0. And we know that the magnitude of volume expansion delta V an object is influenced by three factors. The first factor is the initial volume of the object, V0. The second factor is change in temperature, delta T. And the third factor is the coefficient of volume expansion, gamma. Because of that, the magnitude of volume expansion, delta V, can be formulated as V0 times gamma times delta T. As we can see at the right figure, that after the cube is heated, the length of the cube become L0 plus delta L, and the width of the cube become L0 plus delta L, and the height of the cube become L0 plus delta L. So the volume of the cube is Vt, that Vt equals L0 plus delta L times L0 plus delta L times L0 plus delta L. That we know that L0 plus delta L is Lt. So Vt equals Lt times Lt times Lt. Because we know that Lt equals L0 times 1 plus alpha times delta T, so Vt equals L0 times 1 plus alpha times delta T times L0 times 1 plus alpha times delta T times L0 times 1 plus alpha times delta T. So Vt equals L0 plus L0 times alpha times delta T times L0 plus L0 times alpha times delta T times L0 plus L0 times alpha times delta T. So final volume of the cube Vt equals L0 cube plus 3 times L0 cube times alpha times delta T plus 3 times L0 cube times alpha square times delta T square plus L0 cube times alpha cube times delta T cube. Because of value alpha very small, so alpha square too small. Hence, factor alpha square and alpha cube can be neglected so that Vt equals L0 cube plus 3 times L0 cube times alpha times delta t. Or we can write Vt equals V0 times V0 plus V0 times 3 alpha times delta t. And because we know that Vt equals V0 plus delta V, if we put a magnitude delta V equals V0 times gamma times delta t to this equation, so we can get that Vt equals V0 times 1 plus gamma times delta t. And if we compare the formula Vt equals V0 times 1 plus alpha 1 plus gamma times delta t, and Vt equals V0 plus V0 times 3 alpha times delta t, we can get that gamma equals 3 alpha. To understand more about volume expansion, now let's see the two examples below. Firstly, we will see example 1. An iron bar has volume 300 cm3. Calculate the change of iron bar volume while it is heated from 15 degrees Celsius until 45 degrees Celsius. Coefficient of linear expansion of the iron is 12 times 10 to the power of minus 6 per degree Celsius. From the problems given, V0 equals 300 cm3, delta T equals 45 degrees Celsius minus 15 degrees Celsius equals 30 degrees Celsius, and alpha equals 12 times 10 to the power of minus 6 per degree Celsius. Because this is volume expansion, we need gamma. Gamma equals 3 times alpha equals 3 times 12 times 10 to the power of minus 6 per degree Celsius equals 36 times 10 to the power of minus 6 degrees Celsius. Ask delta V. Answer: delta V equals V0 times gamma times delta T equals 300 cm3 times 36 times 10 to the power of minus 6 per degree Celsius times 30 degrees Celsius equals 324 times 10 to the power of minus 3 cm3. So delta V equals 0.324 cm3. Example 2. At 30 degrees Celsius, the volume of an aluminum sphere is 30 cm3. The coefficient of linear expansion aluminum is 24 times 10 to the power of minus 6 per degree Celsius. If after heated, volume of the sphere become 30.5 cm3, what is the final temperature of the aluminum sphere? From the problems given, we know equals 30 cm3 and final volume Vt equals 30.5 cm3 and T1 equals 30 degree and alpha equals 24 times 10 to the power of minus 6 per degree Celsius. Because this is volume expansion, we need gamma. That gamma equals 3 times alpha equals 3 times 24 times 10 to the power of minus 6 per degree Celsius equals 72 times 10 to the power of minus 6 per degree Celsius. Ask T2. Answer: Vt equals V0 times 1 plus gamma times delta T. 30.5 cm3 equals 30 cm3 times 1 plus 72 times 10 to the power of minus 6 per degree Celsius times delta T. 30.5 cm3 equals 30 cm3 times 1 plus 30 cm3 times 72 times 10 to the power of minus 6 per degree Celsius times delta T. 30.5 cm3 minus 30 cm3 equals 216 times 10 to the power of minus 5 per degree Celsius centimeter cube times delta T. So 0.5 centimeter cube equals 216 times 10 to the power of minus 6 per degree Celsius centimeter cube times delta T. So delta T equals 0.5 centimeter cube divided by 0.00216 per degree Celsius centimeter cube. So we can get that delta T equals 231 degrees Celsius. Because of that, we can get T2 equals T1 plus delta T equals 30 degrees Celsius plus 231 degrees Celsius. So we get T2 equals 261 degrees Celsius. After we have learned about volume expansion and see two examples of volume expansion, now to increase your ability about volume expansion, you can do some exercise from Sains Fisika dan Kimia 7 Intan Pariwara, page 139 number 15 and page 144 number 5. I think that's all our materials in this video. I hope with this material in this video can help you to get understanding more about volume expansion on solid. God bless you.